Welcome to the DIY Honda Garage channel. Welcome to the troubleshooting guide for DTC codes P0100-38 and P0101, which pertain to the mass airflow (MAF) sensor circuit range and performance problem, specifically for the Honda CR-V model from 2023 onward. When the powertrain control module, PCM, detects that the output frequency from the MAF sensor falls outside a predetermined range, it logs these diagnostic trouble codes. The MAF sensor plays a crucial role in determining the amount of air entering the engine, which is vital for efficient combustion. By measuring airflow, it provides the PCM with real-time data, allowing it to adjust fuel injection and optimize performance. If these parameters are not met, it can lead to poor engine performance, increased emissions, and potentially engine damage. Understanding this diagnostic code is critical for proper vehicle maintenance and repair. The error description for DTC P0100-38 and P0101 centers around the mass airflow MAF sensor, a vital component within the intake air duct of the Honda CR-V. This sensor measures the volume and density of air entering the engine, supplying data that the powertrain control module PCM uses to optimize fuel injection and ignition timing. A correctly functioning MAF sensor is crucial for maintaining efficient engine performance and controlling emissions, making accurate measurements essential for the proper operation of the vehicle. If the sensor's output frequency deviates from the specified range, particularly on the lower end, the PCM will flag it as an anomaly and store the related DTC. This could indicate possible wear, damage, or a blockage in related air intake components. The potential causes for the activation of DTC P0100-38 and P0101 can be numerous. A primary suspect is a faulty mass airflow sensor itself. If its calibration is off, or if it has internal faults, it may not provide accurate readings, thus triggering the DTC. Additionally, blockages in the air intake system could restrict airflow, leading to erroneous sensor readings. This could stem from a clogged air cleaner element or damaged intake ducting. Furthermore, any issues within the positive crankcase ventilation (PCV) system, like damaged hoses or valves, can also contribute to this range performance problem. Ventilation systems are integral because they ensure the engine breathes properly by routing gases correctly, and failures here can seriously impact engine performance. Symptoms that may manifest due to DTC P0100-38 or P0101 include reduced engine performance, where the vehicle might feel sluggish or underpowered during acceleration. This happens because the engine's air-fuel mixture is not being optimized adequately when the MAF sensor fails to provide accurate readings. Additionally, you may notice higher exhaust emissions. This is a significant concern, as it may lead to failing emissions testing, ultimately affecting the vehicle's compliance with environmental regulations. Furthermore, the check engine light will likely illuminate on the dashboard, serving as a visual alert that the onboard diagnostics have detected a malfunction in the vehicle's systems. It is essential to address these symptoms promptly to avoid further damage or costly repairs. The first step in troubleshooting DTC P0100-38 and P0101 involves a confirmation procedure to establish whether the issue persists under controlled conditions. Start the engine and maintain a steady engine speed of 3,000 revolutions per minute, RPM, without load, meaning the vehicle should be in either park, P, or neutral while performing this test. Hold this RPM until the radiator fan activates, which indicates sufficient engine temperature has been reached. After this, Allow the vehicle to idle for a minimum of 5 seconds. This step helps to confirm whether the engine can maintain stable operating parameters. If the MAF sensor is functioning correctly, it should provide consistent readings throughout this test. In the second troubleshooting step, the next confirmation procedure requires driving the vehicle at a consistent speed of 37 miles per hour, mph, for at least 5 seconds. This speed represents a common operating condition that the vehicle encounters. While driving, it's important to monitor data from the MAF sensor using diagnostic tools like the Honda Diagnostic System HDS. Maintaining this speed for a duration of 5 seconds allows for an accurate assessment of whether the MAF sensor effectively captures airflow parameters under typical drive conditions. If the MAF sensor continues to produce out-of-range readings during this step, further investigation into the intake system and sensor performance is necessary. The third step in the troubleshooting process involves inspecting the positive crankcase ventilation (PCV) system for any signs of damage or improper connections. The PCV system plays a crucial role in managing engine emissions and ensuring that combustion gases are appropriately ventilated. Begin by visually examining the PCV valve, PCV hose, and purge line for any cracks, breaks, or detachment that might introduce leaks or obstructions to the airflow. Use a visual inspection protocol to also check that all parts, especially those between the turbocharger joint to the throttle body, are in good condition. If any anomalies are found, repairs or replacements may be necessary to ensure optimal functionality of the intake air system, which directly influences the MAF readings. In troubleshooting step 4, focus shifts to a visual inspection of the intake air duct and the air cleaner housing. It's critical to ensure there are no blockages or leaks that could distort the MAF sensor's performance. Examine the intake air duct for any signs of damage or constriction that might restrict airflow. Likewise, the air cleaner housing should be checked to make certain that it is free of debris and that the air cleaner element is clean and functioning properly. A clean intake system allows for proper airflow, which plays a significant role in how accurately the MAF sensor measures air entering the engine. An obstruction in either of these areas can lead to incorrect data being transmitted to the PCM. The fifth troubleshooting step involves performing functional tests on the MAF sensor, beginning with verification while the engine is off. Using the Honda Diagnostic System HDS, check the MAF sensor readings when the engine is not running. Under normal conditions, the HDS should indicate values in the range of 1603 to 10,000 Hz. These values signify that the sensor is functioning correctly. If the readings are outside this range, a fault in the MAF sensor or the intake air temperature IAT sensor 1 may be present. Accurately assessing these values is crucial as they provide foundational data to further diagnose potential issues with the sensor, its wiring, or related components. In the final step of troubleshooting, start the engine and allow it to idle. While the engine runs, once again, use the Honda Diagnostic System HDS to confirm the readings from the MAF sensor. Under normal operational conditions, the expected readings should again fall within the range of 1603 to 10,000 Hz. If this condition is met, it supports the conclusion that the MAF sensor is functioning as intended. Conversely, if the readings remain abnormal, this suggests that there may be underlying issues with the MAF sensor or IAT sensor 1. It's vital to resolve any discrepancies to restore the vehicle's proper performance and ensure that the powertrain control module can effectively manage the engine parameters as designed. After completing the necessary repairs, it is essential to verify that the issues related to DTC P0100-38 and P0101 have been resolved. Start by clearing the diagnostic trouble codes using the Honda Diagnostic System, HDS. Once cleared, take the vehicle on a test drive, ensuring to operate under varied engine loads and speeds to confirm proper operation. Pay attention to the performance of the engine, looking for any symptoms that may indicate lingering issues. If no new codes are generated and the engine operates smoothly without noticeable loss of power or increased emissions, the repair is confirmed. Proper verification is crucial to ensure that work performed was effective and that the vehicle is once again operating within manufacturer specifications. For ongoing preventive maintenance relevant to DTC P0100-38 and P0101, it's crucial to regularly inspect the air intake system. Routine checks should include examining the air cleaner element and ensuring it is free of debris to maintain optimal airflow. Additionally, change the air filters at manufacturer-recommended intervals to prevent clogging, which could adversely affect engine performance. Regularly checking the PCV system is equally important, as any leaks or damage in this system can lead to inefficient engine operation. Keeping these components in good condition will not only help prevent the recurrence of these DTC codes, but also enhance overall vehicle efficiency and longevity. Maintenance practices should be documented to monitor trends and anticipate potential issues. In conclusion, understanding the role of the mass airflow sensor is crucial for diagnosing and addressing DTC codes P0100-38 and P0101 in the Honda CR-V. Following systematic troubleshooting procedures allows for effective identification of underlying issues, whether they stem from the MAF sensor itself, blockages in the intake system, or problems within the PCV system. Regular maintenance practices are vital in preventing the recurrence of these DTCs, thus promoting optimal performance and compliance with emissions regulations. Keeping track of diagnostic trends and embracing preventive measures ensures that the vehicle remains in peak operating condition. By adopting a thorough approach to troubleshooting and maintenance, vehicle owners can help safeguard their Honda CR-V's overall health and performance over the years. Please like and subscribe to the channel. See you next time.